All right, guys, welcome back to part 2 of our word problem video. And we're going to be doing another problem right now. We're going to be going over to section 3.7, number 8 in your textbook. And I have a PowerPoint because, again, it's kind of a long problem. So this says if a ball is thrown vertically upward with a velocity of 80 feet per second, then its height after t seconds is s equals 80t minus 16t squared. And we want to know first, what is the maximum height reached by the ball? Okay, so let's write a couple things down. So first of all, if you want to draw out a picture, because it's always nice to draw out a picture just to see we know exactly what's going on. Someone has a ball and it's being thrown up, so launched somehow. There's our ball, and it goes up in the air, and then it reaches a maximum height, and then it comes back down to the earth, right? And in this scenario, it just goes straight up and straight down, okay? And our position function for this scenario is given to us as 80t minus 16t squared, okay? And if we were to graph this, all right, and think of the position right here, right? So the position at the start is 0. The position at the end is 0. After the end of the scenario is 0. So we definitely know there's those 2 points. And then we hit a maximum height in the middle, right? Because we have this nice symmetry when we throw objects up into the air. And then it, at the maximum height, it starts coming back down. And notice too, this is a quadratic function. So we're going to be getting a parabola, something like this. Okay, so we want to find the maximum height. We want to find the maximum height. And the thing is, we've solved these problems before in algebra. And how we solve them in algebra is we find the vertex. And if you know the vertex, you know the height, right? Because the position function, this is, kind of like the height function. But we're not going to solve it the algebra way. We're going to solve it the calculus way. And here's how we're going to do it. The thing is, when we throw our ball, going back to our ball picture, we throw the ball up in the air and it goes really fast. It accelerates, but then what happens? Gravity starts to pull it down. So we're going to slow, and we stop. And then gravity gradually starts to pull us down back to the earth, okay? And that's what we see here, right? The velocity, you can tell the rate of change is biggest right when we launch that ball. And then our velocity is slowing down till we're at the maximum height. And our velocity is 0 because we're changing direction. Okay, so our maximum height happens when the velocity is 0. So that's how we're going to approach the problem. The maximum height happens in our scenario when the velocity is changing direction or it's 0. All right, so we're going to use that fact. The velocity is 0, and we're going to figure out what time that happens at. We're going to figure out the time when the velocity is 0, and then we're going to take that time and we're going to plug it into our position function, and that will give us the height. Okay, so it's a multiple step problem. So let's start. Okay, so our first job is we have to figure out when the velocity is 0. Okay, and let me change this to make it general to all problems. So velocity is 0. Also, maximums happen when the tangent line is horizontal. All right, which is essentially saying the same thing, right? That means the slope is 0, the velocity is 0. Okay, so what's our velocity? Well, velocity is the derivative of the position function. Okay, so let's see, the derivative of this is going to be 80 minus, bring down the 2, 16 times 2, t. So we're looking at 80 minus 32t. So we want to know when this is equal to 0. All right, so 80 minus 32t equals 0, and we're going to solve it. Okay, so you can solve it a couple different ways. You can subtract 80, divide by negative 32. You can add 32t, so everything stays positive. But however you like to solve that linear equation, you guys should get 2.5. T is equal to 2.5. And t is time, so it's really t is equal to 2.5 seconds. So what this is saying is at t equals 2.5 seconds, our velocity is 0. So that means at 2.5 seconds, we're at the maximum height. Okay, so that maximum height is going to be the position function after 2.5 seconds. Okay, so we have two functions going on at the same time. Okay, so the maximum height occurs at t equals 2.5 seconds. So the max height is s of 2.5. All right, that's the position function. The height that the ball travels is the position of the ball. So let's plug that in to s of t. Remember, s of t is 80t. So 80 times 2.5 minus 16t squared. So minus 16 times 2.5 squared. All right, a little calculator magic on that one. And you guys should be getting 100. And 100 what? 100 feet. Okay, so going up to our original function, the maximum height of this ball is 100 feet. 100 feet. All right, and we didn't solve it using the vertex, we solved it using calculus. And the fact that at the maximum height, your tangent line is 0, your velocity is 0. Okay. Let's see what's in store for us next. What is the velocity of the ball when the ball is 96 feet above the ground on its way up and on its way down? Okay. Let's just draw that. Graph is getting a little bit crazy. Let's draw a new graph. Okay, so we have this scenario. Okay, we just discovered that this happened at 2.5 seconds and the maximum height is 100 feet. And we want to know the velocity. We want to know the velocity when the ball is 96 feet above the ground. So we want to know the velocity at 96 feet. So if we trace this back, they asked two questions. What's the velocity going up? And what's the velocity going down? And we should get some nice symmetry. So we'll see if our velocity mimics that. All right, so how are you going to figure this out? So again, if we want to know the velocity, stop it. If we want to know the velocity is the rate of change, right? So it's the slope of the tangent line. If we want to know the velocity, we want to figure out those slopes. And then that will give us your velocity, because that's what velocity is. It's the rate of change or the derivative of your position function. Okay, so we know the velocity function. That's not a mystery. So we're going to have to figure out what value of, t to plug in. So we're going to have to figure out, we'll just call it t1 and t2. So once we know those times, then we can go up and we can plug it into our velocity function. All right, so let's get started. Lots of steps to this problem as well. So again, this whole thing started, they wanted to know the position function, when the ball was 96 feet above ground. So that correlates to the position function. So when is 80t minus 16t squared equal to 96? All right, so we got to solve this. And it's a quadratic. Do you guys remember the strategy for quadratic? You make one side 0, and then hopefully you can factor and then solve using the zero factor property. If you can't factor, you can always use the quadratic formula. All right, so I'm going to try to keep this positive. So I'm going to move everything to the right. So I'm going to add 16t squared to both sides, subtract 80t, and I'm just going to switch places with the equal sign. So then rather than writing, 0 equals this, I'm just going to move that over there. Okay. And this is actually factorable. So we actually have a greatest common factor of 16. And then let's see, I need two numbers that multiply to positive 6 and add up to negative 5, negative 2 and negative 3. Okay, so we factored it. Now it's time for zero factor property. This product equals 0. It means one of the factors has to be 0. 16 is not 0, so we don't have to worry about that. So this whole thing can be 0 if t minus 2 is 0, or t minus 3 is 0. Okay, so this happens at time equals 2 seconds and time equals 3 seconds. Okay, so that's our T1 and T2. At time equals 2 seconds, we are going up at 96 feet. And then at time equals 3 seconds, we were coming back down and we hit the 96 feet. So now that we know those T's, now we can figure out the velocity at those points. So I'm just going to write it. I'm going to write it right here. I'll use a different color. Okay, so we know t is equal to 2 and 3 seconds. So we have to figure out the velocity at 2 seconds. Our velocity function is 80 minus 32t. So 80 minus 64 is 16. All right, and then feet per second, ds dt, right? Okay, so velocity is positive. That means the ball is going up. And then notice for V3, when we plug in t equals 3 seconds, 80 minus 32 times 3. So 80 minus 96 is negative 16 feet per second. And that's because, let's see, we are going down in that case. We're going down. And again, we do have a nice symmetry, right? Because we see we have this parabola. So the rate of change should be the same. The only reason why they're different is the sign. All right. So there you go. We have one more problem to do, but let's go ahead and do that in part 3.